project, yeah? It's on the Cori cycle.
Cori cycle? What is that? I never heard about that before.
Well, the Cori cycle happens in carbohydrate metabolism, and it happens when the conversion of glycogen to lactic acid in the muscle. When lactic is produced, it goes into the liver to be converted to glucose, then returns to the muscle for metabolism.
Okay. You see, Alia, a scientific explanation.
We have no choice but to know about it. And it's actually a very interesting topic proposed by a husband and wife team, Carl and Dirty Cori.
Hey guys, who's up with us?
Cori cycle.
Whatever that is.
Oh, I know about that. I like this topic because of Dirty Cori. You all know she collaborated with her husband for some research projects, and they used to give her lots of troubles, and when they actually hire her, they used to well underpay her. Talk about sexist behavior.
Actually, it turned out good for her in the end because she was help from her husband who always supported her. She was the first woman to win a Nobel Prize in physiology.
Well, you see that? I like that. Talk about woman power.
Guys, I think they're training myself so hard. I'm so tired.
Oh, please. It's just running. How hard could that be? But since you drink enough water, you should be good.
Actually, it's more complicated than that. Her body is equipped to run longer distances, so the buildup of lactic acid in her muscle would be significantly less than before. And her heart rate would speed up to pump more oxygen and more blood to her muscles faster than you.
And my recovery time also faster than yours.
Recovery time?
Yeah, that's just the time your heart rate only falls 6 30 an hour.
See, Alia overthinking this with all your science. You're giving me a headache. Yeah, how about if I prove all you're wrong? Michaela, I challenge a new theory. To that pole over there. Give me a full piece.
I'm not sure you want to do that. You're not explain yourself.
Okay, I like a challenge. Let's go.
Alright.
Ready, set, go!
Action.
Yeah. Michaela, how do you do this? Because my body trained for it. You're feeling like this right now because of the buildup of the lactic acid in your body. So it increasing the acidity in your muscle cells and this causing a disruption in the enzymes that catalyze the metabolic reactions.
Oh my! That sounds serious!
Don't worry, your body at rest now. The lactic acid will convert back to calories, which allow for an aerobic respiration to take place for your body to recover from a little experiment.
Well, I've learned my lesson. From now on, I will listen to y'all and your scientific explanations. Not me again. But I really do want to know more about the Cori cycle and how it affects exercise. Will y'all tell me more?
Don't worry, we'll do one and show you.
Okay.
What is the Cori cycle? The Cori cycle is a pathway in carbohydrate metabolism that links anaerobic glycolysis in the muscle to gluconeogenesis in the liver. It was discovered by Carl and Gertie Cori. How does the Cori cycle work? When oxygen in the body is low, the muscles undergo anaerobic metabolism to obtain ATP from muscle contraction. This ATP needs to be constantly replenished. The lactate produced by muscle tissues goes into the liver where gluconeogenesis occurs and is converted to pyruvate, then glucose. This glucose then goes back to the muscle through the bloodstream. In this diagram, glucose is converted to pyruvate through glycolysis. Pyruvate is then converted to lactate by the enzyme lactate dehydrogenase. The lactate then goes into the bloodstream and into the liver. Here, lactate is converted to pyruvate, then to glucose through gluconeogenesis. The glucose is then transported in the bloodstream to the muscle tissues for further glycolysis reactions to occur. The significance of the Cori cycle. It prevents lactate acidosis in muscle, and the energy is produced in the muscle during activity in low oxygen levels.
What is lactic acidosis? Lactic acidosis is when lactic acid builds up in the bloodstream faster than it can be removed. Lactic acid is produced when oxygen levels in the body drop. Lactic acidosis is characterized by levels of lactic acid greater than 5 micromoles per liter. The condition occurs when the cells receive too little oxygen. Example, during strenuous exercise. Lowered pH levels are as a result of impaired cellular respiration in this situation. Simultaneously, glucose are metabolized anaerobically by force. Elevated lactate can lead to hypoxia. Firstly, glucose is broken down to pyruvate by means of glycolysis. The mitochondria also oxidizes pyruvate to water and carbon dioxide by means of the Krebs cycle and oxidative phosphorylation. The second step requires oxygen, and the energy carrier, ATP, is produced. Protons are then released during ATP hydrolysis when the muscles are at work. These free protons are incorporated by the mitochondria, thereby preventing buildup of unbound hydrogen cations, maintaining neutral pH. When the oxygen supply is inadequate in a muscle, the mitochondria are unable to continue ATP synthesis at sufficient rates to supply the cell. Glycolysis then increases to supply additional ATP, and the excess pyruvate produces lactic acid, which is released into the bloodstream when it accumulates. While glycolysis helps compensate for less ATP from oxidative phosphorylation, it cannot bind to the hydrogen cation resulting from ATP hydrolysis, therefore rising the concentration of the cations, causing acidosis.
Metabolism is a complex group of physical and chemical processes that occur within a living organism's body in its cells to sustain life. For metabolism, during intense muscle activity, the oxygen supply is deficient since oxygen stores are small, which causes anaerobic respiration. Anaerobic respiration, which uses electron acceptors instead of oxygen, is known as respiration without oxygen. In aerobic respiration, oxygen is the last electron donor in the electron transport chain, as seen below. Although anaerobic respiration uses the electron transport chain, it is not the final acceptor, but it is a less oxidizing substance, fumarate. Muscular contraction rapidly depletes oxygen stores and depletes ATP stores, also promoting the use of anaerobic respiration. Lactate produced in metabolic activity is released into the bloodstream. Note: 2 molecules of ATP can be generated per mole of glucose. Certain factors can determine the rate on which metabolic activity can affect the amount of lactic acid we produce. Firstly, by our VO2 max, which is a maximum rate of oxygen consumption measured during exercise, and is usually expressed as liters of oxygen per minute. Normally, a person who trains would have a higher VO2 max than a normal person, since they have trained their bodies to adapt to more rigorous exercise. More than often, maximum oxygen uptake, or VO2 max, is a single best measure of cardiovascular fitness and maximum aerobic power. Diet. A healthy diet is essential in exercise. Carbohydrates in diet usually provide energy stored mainly in muscles and liver. Protein is also important for muscle growth and to repair body tissues. It is also an energy storage when carbohydrate sources are depleted. A good diet, along with plenty of water while exercising, can boost endurance levels, slowing the buildup of lactate, causing lactic acidosis.
How does the Cori cycle repay oxygen debt? The Cori cycle repays oxygen debt as 4 steps take place. ATP molecules are restored, lactic acid is removed, oxygen is restored, also in the myoglobin, glycogen is restored. The lactic acid built up is taken up by the bloodstream and sent to the liver, where it is converted to pyruvate by lactate dehydrogenase and then converted to glucose via gluconeogenesis. Reaction of lactate to glucose is shown below. The above diagram shows that in the liver, during lactate to pyruvate, 2-NAD plus is converted to 2-NADH, while during pyruvate to glucose, the 2-NADH is converted back to 2-NAD plus. The ATP required for gluconeogenesis comes from aerobic metabolism. The liver uses 6-phosphate for every 2-phosphate molecule made in the muscle. The Cori cycle operates efficiently when exercise has ceased. In order for lactic acid to be converted to pyruvate, it must first be converted to pyruvic acid, then to acetyl-CoA under aerobic conditions. The citric acid cycle and electron transport chain provides ATP to regenerate gluconeogenesis. This process takes place in the mitochondria. The lactic acid that is converted to glycogen is either stored as glucose or sent back to the muscle via glycolysis. Carbon dioxide and water are also formed as a byproduct.